Welcome to the 2018 U.S. Air Force Design Awards. This program, managed by the Air Force Civil Engineer Center, recognizes outstanding designs, focusing on facilities that are not only visually appealing, but also resource and energy conscious. The United States Air Force Design Awards program was established in 1976 to recognize and promote design excellence. Over its history, it has become a viable and important program that is institutionalized within the Air Force. It is widely recognized throughout the federal government and is supported by the enthusiastic participation of notable professionals in the private sector. Much more than simply an awards competition, the winning projects establish the benchmark of design excellence that the Air Force expects for all its facilities and installations. Each year, 3 levels of awards are given: the Honor Award, which is the highest achievement, the Merit Award, and the Citation Award. Let's take a look at this year's award-winning projects. Because the new KC-46 aircraft was still in development, the hangar design was based entirely on manufacturer specifications for size and maintenance needs. The 3-bay hangar was designed for the KC-46A, but needed to accommodate multiple wide-body aircraft to ensure mission flexibility. This flexibility not only affected the building size, it required careful analysis of multiple building components, such as jacking pad locations and high-expansive foam fire protection systems. The hangar is located within a complex of new hangars, requiring architectural consistency, with multiple designers to comply with McConnell Air Force Base's Architectural Compatibility Plan. The LEED Silver certified hangar features light-colored reflective roofing, a highly efficient thermal envelope, and high-efficiency mechanical systems. High-efficiency lighting systems in the hangar bays automatically adjust to daylight levels, while low or zero-emitting paints, coatings, and flooring materials ensure better indoor air quality for all occupants. A robust commissioning program establishes efficient operation, improves occupant productivity, extends equipment life, and reduces ongoing maintenance. Weekly teleconferences with a full design working group help to ensure costs stayed on track. Due to the focus on cost control, the awarded construction cost was $17 million less than the programmed amount. The National Air and Space Intelligence Center required an additional 58,400 square feet of secure laboratory and analytical space to support exploitation of foreign materiel aerospace systems built by potential adversaries and obtained by the Department of Defense. The design met with the unique program requirements and complied with secure facility construction standards, while still meeting with high performance and sustainable building requirements. A central security control office serves both the new facility and connected existing facility, enabling both to function as a single secure complex. Skylights and a light well, each positioned and equipped to block visual and radio frequency threats, provide natural light without compromising security. The architectural form and finishes presents a professional but understated image with simple, highly durable materials and modest detailing. The style reflects that of the connected facility and is consistent with the character of the surrounding area. Bright colors are limited to the restrooms and break area to reinforce a sense of separation from the high security environment common throughout the rest of the building. For optimal flexibility, the facility was designed with the mechanical, electrical, structural, and life safety systems needed to partition the high bay into 3 separate special access program spaces. This allows concurrent use of multiple assets while maintaining security and avoiding extensive modification of the facility's basic infrastructure. The goal of this world-class healthcare facility is to provide a haven for all, an oasis in this extremely arid and rural environment of southeastern New Mexico. Simple earth tone materials create a durable and long-lasting exterior, complementing other base facilities while meeting sustainability requirements. The soaring two-story glass entry facade is the focal point of the building and is highly visible from the street. The interior features high-quality finishes in a southwestern motif that complements commissioned pieces of art. Finishes selected for the building's main medical mall area included simulated stone porcelain tile and warm wood grain ceilings. High ceilings with clear stories let in an abundance of natural light and connection with the exterior environment. Clinic spaces are oriented around 4 courtyards to maximize interior natural light and provide occupants access to areas of respite. Offices are located along the perimeter and around the courtyards to allow staff access to natural light as well. Windows are provided in each stairwell to provide views and daylight into the interiors of the clinics. With an eye on anticipated growth, the plenum was sized to accommodate future communications and fire protection requirements. The use of modular casework and furniture allows flexibility in space planning, maximizing the facility's life. This modularity expands to office and exam room design, allowing for function adjustments. Space is available on-site to allow expansion of the building and parking lot. The design of this new 45,000 square foot B-52 Squadron Operations and Aircraft Maintenance Unit facility is focused on streamlining functional operations while staying within budget. The design improves workflow processes by consolidating operations from 7 facilities into 2 functionally efficient buildings and includes the renovation of a 20,000 square foot neighboring building to provide space for airfield support vehicles and equipment. These facilities give Minot Air Force Base Aircraft Maintenance Unit personnel an efficiently structured space to carry out necessary flight line maintenance activities. Both buildings are designed to maximize energy savings and meet multiple government energy conservation requirements. Each wing of the building can easily be expanded to meet future growth requirements. The facility achieved LEED Silver certification by employing numerous strategies, including increased insulation values, elimination of thermal bridges, air barriers, daylighting, building orientation, and high-efficiency heating and cooling systems utilizing energy recovery. High-efficiency lighting systems, automated controls, and low-flow plumbing fixtures reduce energy and water demands. Located beneath parking surfaces, a geothermal well field serves water source heat pumps. This geothermal system was selected as a result of a life cycle cost analysis and is anticipated to save $2.5 million in life cycle cost savings over the next best alternative. The design of this building represents an achievement in teamwork. The 134th Civil Engineer Squadron led the design, and members of the Training and Education Center were involved in every step of the way, from the point of conceptualization to the selection of audiovisual equipment and furniture. This state-of-the-art training facility meets a significant increase in military education training requirements. The project adds 12 flexible classrooms to the campus. Every classroom is equipped with retractable walls, which allows for additional configurations. Classrooms can convert to a large instructional space or smaller individual classrooms. This project was situated in the middle of a functioning campus, requiring interruption of every existing utility. Utility corridors were established with relocations accomplished in a phased approach to minimize interruption. The biggest challenge was fitting the nearly 50,000 square foot building on a 3/4 acre site with 20 feet of fall across the site. Due to the very limited staging area, the building was designed linearly and constructed from the inside out. The facility is flanked by existing dormitories and a lecture hall and uses similar materials and colors for a compatible look. This renovation of a 45-year-old, 32,000 square foot jet engine shop provides for the efficient maintenance of F-22 engines for the Hawaii Air National Guard. The renovation maximizes storage, improves engine maintenance efficiency, brings the facility into compliance with current codes and UFCs, and reduces resource consumption. The original exterior wall systems and roofing were removed and replaced with a high-performance building envelope. Interior renovation includes structural and seismic updates, electrical and lighting upgrades, improved thermal efficiency, and new HVAC and plumbing systems. Bringing a 1970s pre-engineered metal building into compliance with current codes was a challenge. Extensive testing was done to determine the building's structural integrity and verify it was built according to the original plans and specifications. This resulted in reinforcing some aspects of the foundation and upgrading the structure to resist seismic forces. To comply with base architectural standards, the existing facade was removed and its replacement had to work within the new structural parameters. The facility's exterior conforms with and builds on design concepts for recently constructed, award-winning facilities at the F-22 campus. Architectural features for the Hawaiian environment include hip rooflines, window sunscreens, deep overhangs, lanai space, and outdoor break areas. The interior office spaces use mountable wall systems to provide flexibility for future reconfiguration. This former cavalry barracks is on the National Historic Register. Horses were reportedly stabled in the basement. As an important historical building, updates needed to respect and integrate the parts of the original building most critical for showing its character and heritage. The resulting renovation creates a state-of-the-art office environment for the 55th Wing headquarters, which feels comfortable within a shell of a venerable old building. The building's shallow basement now houses air handlers and ductwork, as well as some programmatic space. The original second-floor restrooms, located on a landing level a few feet short of the second floor. This floor area was raised to match the second-floor level. An elevator was installed to provide accessibility to the entire building. The narrow building's original double-loaded corridor was relocated along one exterior wall to allow for larger office spaces. Daylight is transferred to the interior using clear story and transom glass along the corridor. The design was inspired by original building features. Original cast-iron decorative columns, which were hidden inside walls and column covers, were exposed and incorporated into the new design. Detailing of stair railing, window and door casings, and wooden front porch lattices is compatible with the original style. The new windows comply with anti-terrorism, force protection, and state historic preservation office requirements, while remaining similar in design to the original double-hung windows with divided lights. This vertically mobile laboratory tower supports the Air Force Research Laboratory's next-generation laser-guided weapon development program. The lab could vary in height, being elevated between two open-air steel-frame towers, stopping incrementally from ground level up to 80 feet. Experiments and tests may be repeated at any given elevation in a variety of atmospheric conditions to validate precise test results. This unique facility permits an increase in the number of tests executed and accommodates experiments previously only possible on flying aircraft. This simplifies the testing process and provides tremendous savings to the Air Force by reducing aircraft use. The tower laboratory also protects high-value assets from overexposure to the elements. The laboratory is a steel-framed building complete with electrical, communications, and HVAC systems. The two open-air gantry towers on opposite ends of the laboratory provide lateral stability, a utility core, and a stair access. This unique design required a corner leveling system that can maintain a tolerance of 1/8 inch and remain motionless during testing. The elevation control system is designed to manage a maximum weight of 65 tons distributed over the four corners of the platform. The planetary gears at each corner have locking mechanisms to ensure safety in the rare event of a power outage. Platform stability and vibration dampening is critical for successful testing. The towers have been designed to deflect no more than 100 microradians in a 5-mile-per-hour wind. The full-height towers will resist a 150 miles per hour wind load as required along the Gulf Coast hurricane zone.